Okay, welcome back to another engineering economics video. We are in chapter 7 of the textbook, looking at internal rate of return. So it is just another method to screen projects, to look at a potential project, and based on the money needed to invest in it and the returns it's going to give you in the terms of savings or revenue, it can give us a percentage. And in addition to showing us the percentage of a single project, it can be used to rank projects to tell us which, if given an option of, say, 3 different projects, which one is the best. Now, the downside of using internal rate of return as a ranking system is that it ignores the scale of the project. So the bigger the project, usually, the more dollars that are invested, the more dollars you get in return. So if we look strictly on a percentage basis, a smaller project might have a bigger percentage, and that might make you think, this looks like the better way to go. But if it's going to, let's say you invest $100 and you get a 20% return. That means you're going to make $20. Okay, but what if you invest $1 million and you get only a 10% return? Well, 10% of $1 million is 100,000. So, in that particular example, we're looking at a rate of return of 20% versus 10%. 20% versus 10%, but it's the difference between $20 and 100,000. So it's not always the best method to use, or I guess I should say you need to keep other factors in mind. This shouldn't be the only method used to assess or rank potential projects. Let's look at an example here where we have 2 projects, Project A and B. So Project A is going to cost us $1,000. Project B is going to cost us $5,000. After 1 year, Project A is going to make us $2,000. Project B is going to make us $7,000. So the internal rate of return for Project A is 100%. The internal rate of return for Project B is only 40%. So you might think, oh, well, 100, that sounds a whole lot better, doesn't it? 100% is better. But if we look at just the difference between 2,000 and 1,000, Project A just earned us $1,000, whereas Project B made us $2,000. So Project B had twice the profit, twice the revenue. Now, if we look at the present worth method of analysis, which we looked at in a previous chapter, we could see that the present worth of Project B is a lot higher than Project A. And so if you had $5,000 to invest, which project would you choose? I don't know about you, but I think I'm going with Project B. Now, in order to do Project B, we have to have $5,000 available to invest. If we don't have that, if we only have $1,000, then that kind of makes the decision for us. We need to go with Project A. But if you have the capital to invest, then that frees you up to make the choice, which I think you would make the choice of Project B. So in this slide, this is just kind of echoing what I said before. Project A only costs $1,000, but if you have the $5,000, it would be a good idea to invest in Project B. But this incremental investment analysis looks at, well, let's assume that we take $1,000 out of our $5,000 that we have in our investment pool, and we invest it in Project A. that's going to leave us $4,000 left over that we can invest in some other as yet unnamed project. We don't know what that project's going to be yet, but we work at a company that has a minimum attractive rate of return, an MARR, of whatever. And so whatever it is that we're going to invest that other $4,000 in, we can be confident that it is going to at least earn our MARR. So if the internal rate of return of B minus A is greater than our minimum attractive rate of return, we would choose project B. If the internal rate of return of B minus A is less than the minimum attractive rate of return, we would choose project A. And project A and B in this imaginary scenario, B is the more expensive option. So like in our previous example, it would be the $5,000 project. So let's take a look at an example that demonstrates this. I always feel that examples explain it much better than I can if we actually put numbers into it. So we have a painting company. John is going to start a painting company, or you are going to start a painting company. And you've got two options here. You can go out and buy a small amount of some cheap used equipment, and you can use that equipment to do the work yourself. And so you're going to be doing smaller jobs, so you're going to get paid less. But you only have to invest, if we look at this chart here, $3,000 to get up and running. And so over the next couple years, we'll make 1,350, 1,800, 1,500. Or we can invest more money. We can invest 4 times the amount of the small jobs option. We can take $12,000 out. Maybe we borrow that money from our parents or something. Somehow we get our hands on $12,000 and we go out and we buy bigger, better equipment that'll allow us to do bigger jobs. And maybe we get some helpers. We hire some people to help us. We have some employees. By investing that money and doing bigger jobs, we're going to see bigger revenue. Over the next 3 years, we'd make 4,200, 6,225, and 6,330. So let me bring up a spreadsheet and I'll reproduce this right here. Okay, so I made this spreadsheet here, and if we just use the internal rate of return to compare these two, we would calculate the internal rate of return of this series of values, this cash flow series. And we can see that for the small jobs, the internal rate of return is 25%. I can just copy that over here and see that for the big jobs, it's 17%. Okay, but that's not giving us necessarily the big picture here. What if it's like our previous example here, where even though the internal rate of return is smaller, it might actually be making us more money, not on a percentage basis, but in just a number of dollars basis. So the incremental rate of return would tell us, here's what we need to do. We need to take the big job value minus the small job value. Do that for each year in the cash flow series. And then find the internal rate of return of that series, the cash flow series that is the difference between the big and small investment. And I'll even add a couple extra decimal points there. Actually, it turns out to be 15% exactly. So the example problem here told us that the MARR is 10%. And by doing this incremental internal rate of return analysis, what we found is that by subtracting the small values from the big ones, and then analyzing the internal rate of return of that cash flow series, that's 15%. So that is greater than our MARR of 10%. So essentially what this is telling us is that the big job option is in fact better. It's going to be better to do the big jobs, to invest more money to get the bigger returns, because that's going to end up with an MARR, or an internal rate of return, greater than our MARR. So another way we can think about this is what this type of analysis is saying is that, let's say we do have the $12,000 to either invest in doing the big jobs, or we can invest $3,000 of it and do the small jobs, and that's going to leave us with $9,000 left over. If we took that $9,000 that is left over and invested it in our at our MARR of 10%, would the combination of doing small jobs and receiving this revenue, plus using our $9,000 to get 10%, would that be more or less than if we had just taken the whole $12,000 and applied it towards the big jobs? And what our results here is, what the result is telling us is that no, we're better off doing the big jobs, because this 15% ends up being greater than the MARR. So this gives us a better picture, a better way of evaluating or comparing different projects than just simply looking at the internal rate of return itself. Just looking at the internal rate of return would maybe lead us towards doing the small jobs, but by doing this incremental analysis, turns out that the big jobs is the way to go. Okay, so that does it for Chapter 7. If you've got any questions, be sure to post them on the discussion board or ask them in class.